All right, welcome to the podcast, everybody. I am super happy because we've got fresh news. May not be totally fresh. You may have seen some of it, but we're going to dive into why this is important news. So, my name is Eric Wright. I'm the host of the SNIA Experts on Data podcast here. And I am excited to have two fantastic humans with me to talk about the MRAM Alliance, how this relates to SNIA, what's happened, what's happening, and I guess to kick things off, we'll just do a quick intro just to say who you are, then we'll jump into the subject matter. We'll start with you, Jay.
Sure. So my name is Jay Metz. I am the chair of the board of directors for SNIA, and I've been doing this for quite a while, and basically all things storage.
Nice. And Jack, that's for folks that are brand new to you, which hopefully they aren't, because you got some fantastic stuff you've already shared in the world. And so let's introduce you for folks that are new.
Sure. My name is Jack Gage. I'm chairman of the board of UMEM, an MRAM-based chip company. And I'm also managing director of High10, which is an advisory and investment firm.
Now, the interesting thing about all of the work that's gone on in standards, we've got incredible innovation. We've got the industry is struggling with what is the most starved resource today, and certainly memory is top of that list, aside from dollars to purchase more memory. But we quite literally have a lot of real problems in delivering on the supply that's needed to do stuff. And also, as that's occurring, there's an incredible amount of innovation happening about how do we better optimize what we have in place, what other innovations do we make that can maybe defer the need or remove the need to go down sort of traditional memory growth. Many, many things are impacting a lot of stuff in the industry. But what's great about seeing organizations that are standards based, that have really, really good broad customers and clients who are contributing to those communities, is now we're bringing more and more people with a common goal of making systems better so that we can make people better. And Jay, if you want to introduce what is it that we want to talk about today, what is the MRAM Alliance in relation to SNIA now, and why is this important to SNIA and its community members?
Oh, absolutely. So one of the things that we're trying to do inside of SNIA is look for an end-to-end holistic way of approaching problems that we're dealing with in the data centers now. So obviously we're a storage ecosystem standards organization. And so we've developed an awful lot of standards that people have, they use inside of their, inside of the data centers, they use inside of their laptops, we use inside of internet drives, different technologies that deal with data movement, data protection, and so on. So it made perfect sense that once the MRAM group does its development inside of JEDEC, which is another standards organization. But because of the fact that it's a persistent memory solution, it made perfect sense to fit in with some of the other things that we're doing inside of SNIA. One of the initiative that we're creating is something called Storage AI, which is the approach for how do we handle all of the storage responsibilities that go across the board for AI-based workloads. That's not the only thing we do, but that is one of the things that is incredibly important to a lot of our members, as well as the general conversation going on across the planet. And so new memory technologies, especially persistent memory technologies, fit in perfectly. So we're looking to try to take stuff that is going on inside of MRAM and extrapolate that into other areas that it's related to.
And I guess that's probably why it's important for us to learn what it is that made the MRAM Alliance so interesting and such a fantastic fit. So, Jack, I'd like to actually start from the first principles. What is the problem that the org is, here to solve, and how does it relate in the work that you've been doing?
Yeah. Well, first of all, the memory wall, as it's now more widely known, has been in existence for a while. 5+ years, if not more. Since 2012, the compute has been growing at a rate of 1,000x since 2012. Memory has only grown 30x. So there is a huge deficiency between the rate of innovation in memory and the rate of innovation in the compute. So more than ever now, companies need to consider any new types of memories and architecture as well as interfacing in order to tear down that memory wall. And their MRAM is ideally suited for AI inferencing. I can tell you later on, I've got 8 reasons why MRAM is ideally suited for AI inferencing. So, all of this made that we felt we needed a broader audience to get beyond the existing memory companies that have been doing pretty much the same thing and improving it year over year, but with the same technology, and then be able to open to the world a new technology, again, that's ideally suited for AI inferencing.
Well, it's an interesting thing because in effect, that memory wall creates a Jevons paradox that we have seen a lot of stuff that's moved into changes and innovations around KV caching and how do we better do sort of like storage tier offload where we can still keep things intact, but just move it down to lower tiers. But then again, even in the memory space, how do we better build memory and target memory capabilities based on these new workloads? And inference fundamentally shifted everything because, I don't want to be like every LLM out there. The paradigm has shifted, but we have actually seen that inference is everywhere and it's very unpredictable with how it's being consumed, and it will be for a long time. So this is why you must be excited because you were already the world arrived to where you are, Jack. Like in a sense, and Jay, you've probably seen this as well with a lot of things. Like we've been developing these ideas, and all of a sudden, people are like, "Hey, how do we actually look to what's out there today and put it into the place in the most optimal way?" So, what do you see as like now the sig?
We started this group 3 years prior to joining SNIA. As a small group and growing a little bit, but we felt we needed a bigger platform, which we are, extremely happy since, we joined SNIA in January with the broadening. And that's what we're looking for. We're looking for ways to reach out to system companies. We're looking for ways to get more collaboration because at the end of the day, more collaboration, the market is huge. And more collaboration will yield a better solution, better system solution for those AI, memory issues.
You had me at collaboration, Jay. You and I have been at this for a long time as well through various communities. So, what do you see as like kind of the immediate win with creating this and creating the SIG, and also across the other parts of the SNIA community, where do you see the things plugging in that will both help what Jack and the SIG are doing, as well as bring this whole ecosystem together?
So I think that if you're looking at the life cycle of a workload, and from a very practical perspective, especially for those of us who are geeks and we love to figure out how things work, you hear people talk about things like time to first token. You hear people talk about direct access into storage and accelerated this and accelerated that. But what winds up happening is that you run the risk of focusing on a very small part of a larger puzzle with a lot of moving parts. I believe Jack kind of mentioned it, but I want to reinforce the fact that a lot of these things are not done in isolation. We have the data movement that goes from one place to the other. It's not just that you have an accelerator or a processor. It's not just that you have memory. It's not just that you have KV cache and whatever buzzword happens to be popular in the next month or so. It has to do with how all these things relate together, right? And we see ourselves with a number of different alternatives that are coming out because there are limitations at these kinds of scale. And I don't think that people necessarily understand exactly what kind of scale we're talking about. You know, in certain AI workloads, for instance, it is not uncommon to talk about small, medium, and large size clusters, but people have no clue what that actually means, right? So, in my day-to-day job, for instance, where I am, we consider a medium-sized cluster to be 100,000 GPUs, and that's just the GPUs. That's not counting everything that goes along with it. The storage, the networking, the real estate space you have to put in place for it, right? And these kinds of workloads are very, very, very demanding, but they're also extremely sensitive, right? So you have to put in a lot of protection. You have to put in a lot of security in the right places. And there's so many different things to make the whole thing work. It's sort of like saying, well, I'm going to remove a single lug nut from my car and expect it to work right. And that's just not a very wise thing to do. Well, it's the same thing inside of these data centers, inside of this workload. And AI is only one workload, right? So
Right.
what we're trying to do is say, look, as we start to figure out, how do we get a better, a better piece of the puzzle? Where does it fit into the overall, the overall overall, technology architecture? There are consequences, there are trade-offs that have to be made. And what we do at SNIA is we look at those consequences and we work with other organizations like JEDEC and a few others to make sure that this actually is a smooth transition from, a more traditional data center type of environment to a very workload specific environment. So it's very important to us that we figure out, in advance so that people don't learn the hard way, what the trade-offs are going to be and what they need to be.
Yeah, it was funny. I was in a DR discussion with somebody about a storage solution, and the question came up that I hear that there's an issue with like kind of a full like rack row level failure that could cause a problem. I said, if you're an NCP or if you're a Neo Cloud and you lose a whole row and you have no other backup for it, yes, that's a problem. Like the localized things that we're thinking about don't come into play the same way when you, as you said, like kind of scale it out, where we're not thinking about rack level and server U level. We're talking about row scale and data center scale stuff. So, Jack, as you've been developing and looking at where these technologies apply and what are the use cases that match, what's in the MRAM Alliance portfolio of hardware tips and tricks, that has created now what will be a really strong opportunity to build around stronger and faster, yet, at scale type of memory implementations.
Yeah, as Jay mentioned, there's performance issues or performance metrics, like time to first token, and then, token throughput. There's also power-related constraints. Right now, those racks are just, gobbling power, and you need close to a nuclear power plant to power the new data center. So it's going crazy. And one of the two of the 8 reasons MRAM is ideally suited for AI inferencing is one, it's fast. It's really fast and low latency. It is much faster at a bit cell level than a DRAM. And the latency, because it's a direct read, just like an SRAM, is really low. So you can get latency on the first token less than 10 nanosecond, which is blazing fast. And you can run that MRAM, with an engine, you can run it basically maxing out the process frequency. and it doesn't matter which process it is. So you can get really fast throughput and really low latency. And also this memory is able to retain data uh, without power. So you can, and you don't have any refresh, you don't have any of this overhead. So you can achieve a very low power with that. So as Jay mentioned, we're totally aligned with the SNIA, even prior to joining SNIA, which is we want system companies to learn more so they can do a better job at fault and not learn, by their mistakes. We want to reduce the number of mistakes they're making and speed up their time to adoption and time to market. And right now we're embarking to it's a new initiative we have, which is on the system design side to be able to, by application, explain and give guidelines to companies on how they can incorporate MRAM and what things they should be careful in doing their system design. And we'll expand that to webinars, we'll expand that to FAQs, so we can get the word out, and again, as Jay's saying, make people's life easier.
Yeah, it's great that, I'd say the education is one of the most powerful things that we, even if you go looking for it individually, I may go dig and find some things and I'll individually learn some things, but inevitably when I get to SDC and you have extended conversations with other people who've also done their own research, then now you're actually working in that collaboration and there's a persistence in the collaboration versus me, like, I'm just going to build one thing for my specific purpose and I'm in and out. But being able to move this in and have that SIG approach means you get the right backing as far as governance and everything to keep the lights on for the org, but also just now you get access to all these fantastic technologists who are as excited as heck about this stuff as us, which maybe that tells you something about us, but I'd say I'm pretty damned excited about what the heck is in front of us. Like, especially when you get to low power, we're seeing way more things around inference at the edge, and we actually know what the edge is now. It's not what it was 8, 10, 12 years ago when somebody invented it. And thank God we didn't land on fog. But here we are. Like, we are legitimately seeing small footprint, small power footprint inference capabilities that are going to need this type of memory access and persistence, because you solve one problem, you create 10 others. So it sounds to me like
bringing AI close to the edge is also a power reduction, because now you don't have to transmit as much. And we know the wired and wireless transmission, especially wireless transmission, tend to burn a lot of power.
So Jay, because this is obviously, we'll say we're AI focused in the discussion, but do you find is that like kind of the biggest conversation right now inside SNIA and with some of the like your own like other community partners?
You mean AI in general?
Yeah. Like we obviously we're a bit hyper focused on inference in a few of the discussions we have, but I don't think that we're alone. I think this is like a very strong collective problem we're trying to solve together.
Oh, I think you're right. I mean, it would be disingenuous to say that AI didn't bring up a lot of the conversations. However, I do find it is somewhat fractal, right? So it's just one stage amongst many in that level of discussion. Ultimately what we're trying to figure out is how to make data movement more efficient overall, period, regardless of whether it's for AI or something else. And the everything that goes around it, everything that surrounds that question is fair game for conversation, right? So when you think about storage, and I believe that one of the big problems that we have is that a lot of people who are not storage oriented don't really understand what storage means, right? And storage has one job, Give me back the correct bit I asked you to hold on to for me when I ask for it. And everything that goes around that is all part of what we have to do. Now, different people are going to focus on different things, right? If you're focusing on the capacity of a drive, the bit that I asked you to hold on to is what you're going to remember. If you're going to be an application person, you want to be the correct bit, right? If you're an end user, it's when I ask for it. But if you happen to be, a lot of the members inside of SNIA, not only do they have to deal with all of that, but it's give it back, right? Give me back that bit. And that word give is one of the things that is the most difficult to do correctly and efficiently. Because every time you have to give, you have to find the trade-off about accuracy and resiliency and security and reliability. And the best bit that you have to send is the one you never send, right? So if I don't have to send an IO, then that's great. But if what I'm doing is I'm just basically kicking the responsibility to someone else, not so much. So it's important to note that we all have to take a look at all of these different these concentric circles of influence with the technical architectures. And every single stage along the way, you've got the physical aspect of it, you've got the networking aspect of it, you got the memory, and so on. It's like somebody standing on Times Square. I got your MRAM over here, and I got your DDR over here, and I got your gold watches right here. So what we need to do is we need to say, all right, how are all these things supposed to be working in concert together? And that means that it used to be that SNIA did some of this, and NVM Express did some of this, and OCP did some of this, and JEDEC did some of this, and DMTF did some of this. It's not now the problems are so big and so involved that SNIA works on a large portion of it, JEDEC works on a large portion of it, OCP works on a large portion of it. So even something as focused as MRAM has implications beyond SNIA, beyond JEDEC, into other areas. And you need to be able to have the conversation at all of the different levels if you're going to have any credibility. Right. And so, Jack's talking about wanting to get people involved in doing this. It's like, yes, because of the fact that the tail of influence is extremely long now.
Yeah.
Right. And it's something that if you're not careful, you could find yourself on the business end of a customer hissy fit. And I don't think anybody really wants that.
This is true. Yeah. So Jack, with that, what are some of the other use cases that are maybe not necessarily AI centric, but like what are the more, enterprise use cases and other use cases that you've already seen come out or that you are seeing as opportunities for MRAM as a spec?
Yeah. First of all, Jay is right on. So, we're totally aligned.
Can I have that in writing? I want to pass that on to.
Yeah, and on the give difficulty to accurately and efficiently pass on the data, that is reason number 3. MRAM is ideally suited for AI inferencing. It is one of the newer memory that is the most reliable. So reliability is extremely good. And it's also very high endurance. And so, going to the question you asked about applications, it does have a wide range of applications because of that, including automotive. Right now, you see companies, the big automotive chip companies, making AI-based, automotive MRAM-based chips, not only for AI, but for a wide range of applications, including microcontrollers. Staying on the reliability, and also the fact that inherently, because MRAM is not a transistor-based technology, MRAM sits between 2 metal layers on top of the active layer. So because of that, it is very resilient to radiation. So when people are talking about data center in space, it is a lot easier when you have a technology that is resilient to radiation and soft errors. But in terms of application, it's pretty wide. I mean, it goes from, smart cameras, and there are some right now being designed with MRAM to applications like AR, VR, ultra low power application, because you can shut down the system. Say you have a smartwatch and you're sleeping, you don't need that memory necessarily to be live. It's that your watch is not doing very much. But right now, it's hard to shut it down because you don't have a memory that is fast and that retains the data. So with this, you can really play and be able to have different level of, sleep modes where you can gradually and gracefully lower the power. But that scales all the way to data center, because since this memory is bleeding fast for inferencing, you can scale that all the way to data centers.
When we're seeing more of just the right patterns as we learn, we couldn't necessarily have predicted how the write patterns and the storage patterns will go for these workloads. And even as we go, so definitely durability, the endurance of the actual hardware, the fact that you can subject it to pretty harsh conditions, that's, again, these are things that they may have seen like unnecessary for most of the use cases we have 2 years ago, even, probably even 6 months ago would have been like, oh, it's interesting. But when you dig in and you look just in a few minutes, you've already hit, this is a very, very important technology. And so, super exciting. So what do you see now? What's the best thing for folks that do want to get involved? Jack, I'll start with you. What's the way that you want to engage via the SIG? And then Jay, I'll have you kind of close up and talk about how to connect.
Yeah, well, first of all, SNIA is a platform, and you can find us through the SNIA platform. We have a booth, SNIA booth at in the exhibit hall of FMS, which is going to happen early August, Future of Memory and Storage. And we will have demos at the SNIA booth. So, if you want to learn more about what we're doing, I will give a talk at FMS. We will have a chat with the experts. So that's a good forum if you have time during the day or Wednesday evening to learn more. And we will also be present with multiple talks at the SNIA SDC. And then later on this year, we'll have the Global Forum. So many ways to find out more about the MRAM Alliance and how you can join and how you can get involved, either on the overall Alliance SIG or one of the sub-SIG we have, subgroups. As I talked about earlier, the system design with MRAM. Memory interfaces, that's another point, basically in this, give back accurately and efficiently, transfer the data back. So memory interfaces so that we can play along, because it's a multi-memory type system in order to optimize the architecture. And then we also have a roadmap track, which kind of goes over what's coming in the future.
Fantastic. Well, looking forward to FMS. I'll be there. Strangely enough, they allowed me to speak at it, so I don't know who they might have a low bar there, but so it's going to be exciting. And
one can relate. I'm in that same boat.
So we can all enjoy. We will be there to put you through the test, Jack. We're going to put you through the technical exam. But Jay, what's ahead, and based on this, and what do you recommend for folks when? How do they engage both with SNIA and with Jack and the folks through this SIG?
Yeah, well, Jack was absolutely spot on about the upcoming events. We've got a number of things that are going on. I mean, as we're doing this recording, we've got the FMS presentations that are coming up. We've got the SNIA Developer Conference in September, the AI Infrastructure Summit, the Supercompute, SNIA is going to be at all of these things. But beyond that, there's the ongoing information that we have at SNIA.org is incredibly important for people to be able to keep the updates and see the webinars that Jack was talking about and the integration that's going on, and to participate in the storage AI community is absolutely incredibly important. The key thing I think that is really missing from a lot of the discussion, and I believe SNIA is stepping up for this, is that a lot of times people are just sort of saying, well, this is what's going on. These main big companies are kind of pushing this on us. I don't really have a voice. This is the opportunity to have a voice. This is the chance for people to say, you know what, I want to have some thoughts in the open discussion, and that's exactly what SNIA offers. You have the opportunity to share your voice, share your ideas, and even influence the way that the direction works for the entire ecosystem. And so by joining, SNIA.org or SNIA.ai, if you want to be specifically for the AI stuff, both of those are great options, even beyond the events that are coming up in the next few months.
It's going to be, I think we're going to see more and more of these smaller events and smaller get-togethers, because it's eventorama right now with all these AI use cases coming up. So I'm glad to see fantastic minds coming together. Looking forward to seeing both at FMS and at SDC. And for folks, of course, you can check out the links below. We've got links to, and if you just do a search for MRAM Alliance, the beauty part, it'll take you right to the main page. It'll pull you into the SNIA org. Get on in. If you're not already a member of SNIA, then, well, you're a wrong person. Go do that thing. Go get in charge into SNIA. There's a fantastic group of humans. And
I would say it is also affordable, as SNIA has different rates. So for smaller companies,
exactly,
make it very affordable to join SNIA.
Yep.
Yeah, and that
we're very startup friendly.
It's super important, because nowadays, the last thing you want is to join, there are obviously sort of very vendor aligned things that end up having to happen to a lot of these hardware communities. And then next thing you know, they're burning their entirety of their budget just to be able to participate with an upstream, player. And that's tough, where this is much more broad ecosystem coverage and international too. So that's the other thing, is there's regional events, there's community members from all over, and it doesn't end when SDC closes the gate at the hotel. It continues online from that moment onwards. So there's lots of ways to keep engaged. So I'm excited. All right. Well, so let's just do a last little quick recheck. So Jack, where do folks find you if they want to get connected with you? And you can feel free to say at SNIA.org is a great place to find you, because I imagine there's a few places to go.
Yeah, I would say at SNIA.org or SNIA.ai. That's probably the best place to find us. Or, you can Google us, or you can use AI to find us.
That's it. It's always neat to be consumed by the very thing that we create. Jay, for folks that want to get connected with you, and how do they do so?
I think probably the best way to do that is to, as Jack said, I can be reached through SNIA.org, but also on LinkedIn and the usual social media channels. Excuse me. YouTube. I've got. I'm starting to get back into doing some more blogging on my own site, jmetz.com. So you'll see some other things in a variety of different places, but I'm sure you'll probably hear from me somehow.
And also, for folks that didn't get a chance to see it, Jay did a really great presentation on sort of some of the stuff that SNIA is handling at a Tech Field Day, which is a sort of a non-vendor-ish community of practitioners. But it was a great presentation. It's available online. So if you just do a search for Jay Metz at Tech Field Day, you'll find a lot of content. Look for the most recent one. So that was a great presentation, really kind of diving into the problem. And that reminded me that as smart as all of these amazing humans are that we're surrounded by, we forget that things have changed. And we have this sort of like assumption that everybody just is caught up on how AI consumes storage. And it was wild to see some of the questions that I wouldn't have expected from really, really super smart people that have been in the industry a long time going, oh, right, we need to keep educating and we need to keep learning. So I'm looking forward to learning from both of you. So Jack, Jay, thank you very much. And for folks, of course, again, follow the links, get involved with SNIA, and we'll see you all on the next Experts on Data podcast and live at FMS and at SDC.
Thank you. Bye.